Hello and welcome to another GTC session. My name's Adrian Graham, and today we're going to look at a CloudXR solution running on Google Cloud and how to expand it for enterprise users. I've spent about 20 years in visual effects and animation building pipelines. Then I moved on to work at Autodesk as a product designer for Bifrost and Maya, if you're familiar with that. So there's some simulation component there, and there's lots of data to store and move around and compute and organize and sort through and search through. And finally, I've been at Google as a senior cloud solutions architect for about 5.5 years now. And I've worked on a number of areas of work, some of it in media and entertainment. And most recently in the last year or so, I've moved into the cloud gaming team. You've probably seen me at some other GTC sessions. For example, we sort of looked at the evolution of building a virtual studio on the cloud. And back in 2019, it was still a bit undefined. So I walked through a number of scenarios and possibilities and potentials and showed some of the basic building blocks of building a cloud studio for content creation, such as game development or film and visual effects, animation, or even any type of HPC workloads. And then the solution grew and we were able to start implementing it with some actual customer workloads. As you can see in the 2020 presentation, I talked about some of the actual customer use cases that were out there. Customers started using not only virtual workstations, but also expanding their facilities to incorporate multiple regions. So they had multi-region deployments in different continents, different parts of the world, and they're able to get data back and forth between them. And then last GTC, which was also in 2021, but in spring, I introduced the notion of VR and AR workloads, leveraging NVIDIA's CloudXR. And this was basically some of the early days of CloudXR, showing how to stand up a workstation and how to install and run CloudXR from a remote workstation on the cloud to a tetherless headset. And we're going to look at that today, but we're also going to expand on that solution because we've sort of evolved and we've been able to incorporate a lot more of the traditional production tooling that is required. So let's look at what we're going to talk about in specifics today. We're going to define the solution. I keep using this term solution. What is the solution? What is it composed of? And what does it need to do? We're going to look at some specific use cases of VR and AR that are in use today, not necessarily on cloud, but I'm going to talk about how these could be moved to cloud and what the benefits are. We're going to look at some of the requirements of what VR and AR sort of push the boundaries of, like what is required in order to deploy this type of workload. I'm going to introduce a new feature in our cloud marketplace. NVIDIA has launched a CloudXR solution within the Google Cloud Marketplace, simplifying the deployment. And then we're going to take that sort of building block and I'm going to show you how it could be part of a bigger sort of enterprise deployment. And then finally, we're going to look at how this can be expanded even further by leveraging something called the Collab Viewer from Unreal Engine, which allows multiple users in different locations to visualize in VR the same scene and collaborate. And then I'm going to talk about where we're going to go next and what we're looking forward to in the future. So let's have a look at the solution itself and what's required. First, we need a scalable solution. Clicking one button to get one workstation with one user's VR back end isn't really going to scale. If you have hundreds of users, you're not going to do that hundreds of times. So you need something that can expand easily and is programmatic enough so that you can make one change to affect all the users and onboard people easily, as well as provision and deprovision their resources. And you also need it to be able to stream AR, VR, and mixed reality content, which obviously we're going to use CloudXR with, but that entails the installation of a number of libraries, and there's some licensing involved, and we'll talk about that a little deeper. In this case, this part of the solution, or this sort of variant of the solution, we're going to focus on enterprise. And I do that because I want to sort of differentiate enterprise workloads from other workloads. Another workload might be like a web scale workload, where you may have tens of thousands or hundreds of thousands of users around the world. We're not going to focus on that because some of the benefits of this really shine when it comes to enterprise workloads, where you've got customers that have a very specific need and have very well-defined requirements to solve a particular problem. And that could be built programmatically and solved within this sort of ecosystem and within this solution. And like I mentioned earlier, you should be able to provision and connect to these resources easily and retire them or delete them on demand, because you might have users coming and going. You might scale up your team to hundreds of users for a few weeks and then scale it down to only a core group. And you need to be able to do that easily and in any region. And also there needs to be some sort of intelligence built in so that you can connect users to the resources that are closest, as close as possible to them. Latency is obviously a big factor with AR and VR, and we talk about that in some of the previous GTC talks. But we need to provision these resources in the right location and connect the user with the least amount of sort of hops, latency hops. And finally, this should be easily repeatable and extendable. You should be able to deploy this infrastructure within an organization, within a project, and then be able to deploy a new project in a different region or in a different number of regions. And it should be programmatic and organized in a sort of very DevOps-y type of way. Let's take a look at some of these workloads that are in use today by customers around the world. The first use case I want to look at is architectural visualization. And there's this really neat sort of inception scenario of a company that built in Unity a walkthrough and architectural visualization of Unity's London office. This company called Oneros did the build in collaboration with Unity. The office itself, the physical office, was designed by M. Moser Associates. But there's a really cool blog post here by a person named Ronan Beckerman, and you can look at some of the sample scenes here and some of the environments that's been built for this sort of validation of VR walkthrough. And if you go through this site, you could see some of the captures, and also some of the different ways that you could visualize and walk through the office and look at it in different parts of the office at night. And because there's real-time ray tracing and reflections happening and environmental lighting and everything, it all looks really beautiful. And then there's some links to some YouTube videos showing the actual walkthroughs. Really gorgeous stuff. These are obviously higher quality renders and they're not VR walkthroughs, but just to give you an idea of the level of detail that's gone into this project. Another use case we're seeing out there is a big automotive customer in the retail world and as well as the design world. BMW is using Epic Games. They've partnered very closely with Epic Games and their Unreal Engine team to do vehicle development and visualization at the early stages. You can go through this blog post from BMW that shows how engineers are visualizing the car and the interior before any development even starts, before physical development starts. Another interesting use case, which is actually pretty broad application, is for training. And in this interesting use case, Boeing is conducting training for astronauts using a new headset by a company called Vario. And they're essentially having the astronauts train start to finish of the commanding the spacecraft entirely within VR. And just to sort of tack on to this notion of training, there's a perfect scenario for a cloud deployment to provide students and people learning the sort of to democratize their access to all these resources and to give everybody the same type of headset, give them access to the same virtual workstation that has the same content on it, no matter where they are, allows them to have the same training experience, no matter what their location is, with only a minimum bandwidth requirement. So that's a pretty great application for CloudXR on cloud workstations. The next use case I want to show you is dealing with content creation, and I've sort of mentioned this a few times before. But one of the big use cases I want to look at here is actually one of them that I had a part of in the last GTC, which was introducing a company called Masterpiece Studio using a piece of software that they developed to develop characters in VR. You could see this actually is an NVIDIA branded video. So I encourage you to go and check out Masterpiece Studio and see what the interactivity is like and see what it's like sculpting and creating and texturing and designing characters in VR, which is actually a pretty cool way of interacting and interfacing with this workflow. So this is sort of what we're seeing, some trend towards this of content creation in VR. And this works directly on the cloud. You could see there's some mention here of this running on Google Cloud, which is it's pretty cool. And the last use case I want to look at is experiential. And by experiential, I mean sort of these interactive VR experiences that customers want to deploy to allow for tens or hundreds or thousands or tens of thousands of users to be able to access. And this is a really interesting use case of a partnership between Sony Music and Unreal Engine and Madison Beer, pop star. They basically built a digital environment based on a Sony presentation space, and they put Madison Beer in a mocap suit, and they did a full body scan, and they were able to build an entire experience virtually that you could put on a headset and sit through this concert and get front row seat to some sort of exclusive concert that I believe ran on TikTok Live. So if you can imagine taking this one step further and being able to deploy this for tens or hundreds or thousands or tens of thousands of fans. In order to do that, you need to be able to expand your fleet of resources dynamically, based on demand, based on region, based on time of day. This is very similar to sort of a game rollout, in which you've got a fleet of resources that could scale up very quickly to meet demand and then scale down when the event ends, for example. Let's have a look at what some of the requirements are to run these workloads. Well, the first requirement is that it should be easy. The user in the VR headset or on the web shouldn't have to do anything other than just click a link. Whether you click that link and launch a separate client, or whether you're in VR or AR and you click that link and it launches a workload remotely, thereby connecting you to some sort of via some sort of port to a browser window or something. It should be as simple as that. And when I say the experience should be indistinguishable from a physical resource, meaning the latency and the jitter and lost packets and everything should be as good as, if not better than, a physical resource, i.e. A workstation that sits under your desk. One of the advantages of these tetherless headsets is that you don't need a $10,000 workstation with a very expensive graphics card running under your desk. You can have one running on the cloud only when you need it. The next requirement looks at adaptability. And when I say should work on a wide variety of hardware, it shouldn't really matter what headset you're using or what, if you have a workstation or a laptop, and you're running in a 2D environment or a 3D browser environment, it should be sort of agnostic to what hardware you're running, and also under a variety of conditions. And by this, I mean bandwidth variability or latency, variable latency, where maybe you're running off a hotspot on your phone or you're using a 5G connectivity or something like that. The stream protocol should adapt to all that, and the solution should be able to handle those types of variabilities. And like I've been saying before, there's this notion of individual and enterprise scale and web scale. And can this solution scale to thousands of users or tens of thousands of users? It depends on what you're trying to run. And it also depends on what the workload is and what how many concurrent users and how long the sessions are, for example. And finally, this solution needs to be flexible in order to accommodate these workloads. We've seen a lot of use cases already, and we talked about the difference in runtimes and persistence. What if a user wants to keep their session and put their headset down and go take a break or go off for a few hours and then come back and pick up where they left off? How do we solve that problem? How do you store that in memory or keep the session persistent so that they can reconnect immediately? But you don't want that session to have to keep running while it's idle. Can you offload the contents of that to a storage that could be sort of replenished from this offline storage back into an interactive environment quickly as soon as they put the headset back on? So today I want to introduce a new solution in the cloud marketplace. It is by NVIDIA. It is a CloudXR solution that you could deploy from marketplace. And it includes a number of things that simplify the deployment of a standalone virtual workstation that you could run a CloudXR workload from. To go over some of the components of it, it includes the CloudXR SDK, and we'll look at how to install that. It includes the graphics drivers, which is the virtual workstation drivers, or also known as the grid drivers. It also incorporates licenses, and there's 2 licenses required, actually 3. One is a Windows license, and that's sort of outside of the scope of the NVIDIA solution, but it's running a Windows Server license anyways. And then there's NVIDIA Grid license, which provides you with acceleration for desktop acceleration, for multiple monitors, for resolutions above HD resolution. You can go into 4K and above, multiple monitors, 60 frames per second. And it also includes the new CloudXR license, which is, you can see this is an introductory offer. So they're still working out some of the logistics behind how to license this and how to acquire a license. But in this case, you acquire a license automatically. You don't even have to think about it. The deployment, the infrastructure that you deploy runs in your own project. It's pretty simple to get up and running in a fresh project or into an existing project. And finally, the costs for the licenses and for the infrastructure themselves are fully integrated into GCP billing. So you'll see it as part of your billing reports as its own SKU, which is really interesting. So then you can isolate exactly how much money is being spent on any particular component of the solution. So let's jump in and have a look at how to deploy one of these from Google Cloud Marketplace. So I'm in the Google Cloud Marketplace main screen here. And if I look for all of NVIDIA's solutions, I could see quite a list of them. Some of them overlap, like the virtual workstation, the RTX virtual workstation. And the CloudXR solution is sort of built on top of that. It's got the same drivers and licensing, and then added on top of that is, for the CloudXR offer, is the CloudXR SDK and the SDK license. So let's click that. And the main page, you could see some of the overview. This is, by the way, an introductory offer. So this is just being rolled out, and pricing may change, your mileage may vary, et cetera, et cetera. There's some explanation as to what it's all about, some of the costs. One thing to point out here is the NVIDIA Grid and CloudXR licenses are combined into 26 cents an hour. The Grid license is typically 20 cents an hour, so CloudXR is an additional 6 cents an hour. Let's click Launch at the top and start to configure our custom CloudXR workstation. I'm going to call this CloudXR. I'm going to call this CloudXR Demo 01. I'm going to choose the zone, and I think maybe I'm going to put it in the Las Vegas region. This is a relatively new region. It's got T4 GPUs, and it's very low latency to where I am physically. I'm in Los Angeles. For these workloads, I think 8 vCPUs, the default, is a little too low. If I'm going to be running applications like Unreal Engine, I'm going to need some more power. So I'm going to select a 16. You can go up to 24 vCPUs with a single GPU, a single T4. So if I wanted to do that, I could change it to custom and just dial in 24. But I'm going to leave it at that. Speaking of N1, you can only attach these types of GPUs to N1 type machines. Even though the solution allows you to choose E2s and N2s, you can only attach it to N1. So leave it at that. Obviously, only the T4 is available in this region. I could choose multiple GPUs if I wanted, but grid acceleration, NVIDIA grid acceleration only occurs on the 0th GPU, or the CPU in the first, GPU, the GPU in the first position. So each additional GPUs will be present, and if you run any compute workloads, they'll take up the load. But visualization is only accelerated on the first GPU, so leave it at 1. This is grayed out because the NVIDIA Grid license is already included. Ignore this message here. You can just leave that unchecked. We could choose the disk type. Balance gives us a little bit more performance. The default boot size is 100 gigs. You can go above that. I wouldn't recommend going below, even though it's possible. For our uses, I'm going to set this to 500 gigabytes. You can go up to 64 terabytes if you like. You could choose which network you want to run on. I have a bunch of different networks and a bunch of different subnetworks. If you have a default network, then there will be a subnet in every region, so you don't have to worry about the CIDR range, the IP range, or anything. And then finally, firewall rules, and this is part of the deployment manager structure. If you leave all of these blank, and CloudXR requires a number of firewall rules, admittedly quite a few. It also includes 3389 so that you could RDP into the machine to access it initially. If you leave all these blank, it will allow network traffic from anywhere on the internet through these ports. So you probably don't want that. What I would recommend is putting in your own external IP address, and to find that, you could very easily go to ifconfig.me, and it'll spit out your IPv4 address. For now, I'm going to grab this IP. This is, by the way, I'm recording this from home. This is my router's IP address, so it doesn't need to be associated with any device on my own private subnet. This is my router's address. You can also get this by curling ifconfig.me in a terminal if you want to do this programmatically. I'm going to paste this in all these fields and accept the terms and conditions and click deploy. And what we're seeing now is Deployment Manager going through the template. You can see all these files are part of the template, and they contain configurations to deploy all of the necessary resources. And that's not just deploying the instance, but also the firewall rules, and it's doing checks for network connectivity and availability in particular regions. You can see it's already done a couple of them. And if I hop over to my VM instances compute engine section of the console, and I refresh, I can see that my workstation is being created currently. While the workstation is being created, let's go and look at the deployment guide. So I urge you to read through this. It's not that long. It's only, it's only a few pages, but it shows you what's included and what is not included. So we are going to get a virtual workstation that has an NVIDIA GPU attached. It's got the NVIDIA drivers, the latest drivers, Grid 13 or vGPU 13. Firewall settings are set up, and a CloudXR server installer. So it's not installed, and I'll explain that in a minute, why it's not installed, but the SDK is ready to install. That's one of the things, one of the benefits of running the solution is that it sort of simplifies a number of things for you. There is also a couple things that are not included, and it's important to install Steam and Steam VR. That's sort of going to be our portal into the Open XR stream that we're going to activate from the remote workstation. We need to install something other than RDP. RDP comes by default included with Windows Server images on GCP. So for reasons down here, you cannot use RDP because there's a Microsoft display driver conflict with CloudXR, the way CloudXR works. So we're going to install something else. You could install a free solution like VNC or an enterprise paid solution like Teradici or Parsec. I'm going to install Teradici. We also need to install a client on a headset, and I'll show you how to do that. I know a CloudXR client, that is, and then whatever OpenVR applications you want to stream. And we could just use SteamVR and play around with that. Something else important to point out is how we're going to log in. I urge you to read through this in its entirety, but I'm going to skip down to this section where it tells you that there is a user named GCP Streamer that already exists on the instance or on the template, the disk image, I'm sorry, that is included with the solution. You can use this, but you could also log in with your own user account. If you go, let me refresh here, it should be stood up by now. If I click this down arrow, I could go set Windows password, and what that's going to do is create a user account and random temporary password for me to log in via RDP to this Windows workstation. However, you don't want to do that because this GCP Streamer account has all of the has a number of things already ready, placed in its home directory for you, including the CloudXR SDK. So we're going to log in using that. So once this is now stood up, let's go back to the deployment manager and just double check everything is finished. And we can RDP. You can click this RDP button. However, that is, I believe, going to be deprecated in the near future. You can download an RDP file and run that with your favorite RDP client. I'm going to launch my client in a second. So I've got my RDP client going. I'm going to paste that password, that random password as part of the documentation, which I will want to change immediately, and I urge you to do the same. And I'm going to connect as GCP streamer. Okay, so you could see we don't need networks. We can close the server manager. So we could see immediately there's a few things on the desktop that are useful. Number one is the CloudXR installer. There's the installer there. We're not ready to install that yet because if we look back at the documentation, we're going to see the steps required here. So there is a README. I'm going to go back to here and click on README, and this is a very helpful step through. Double click this. The quick start steps: download Steam VR. It's important to note you need to download Steam and install it, and then download Steam VR and install it and run it. And what that's going to do is install and run a number of libraries, important libraries that CloudXR needs to run. So I'm going to do that and then pause the video and then come back when it's done. So now that I have installed Steam and Steam VR and I've run both of them, I can quit out of Steam VR. The very first time Steam VR runs, it's going to install a bunch of Microsoft redistributable libraries, which is important. So now we're ready to install the CloudXR SDK. So I'm going to open that up and open the installer and run this exe. And I want to install everything by default. I can leave off the client program because there is no client. This is the server that I'm installing, and hit install. And once it's finished, it will launch Steam VR for me, which is pretty handy to show that it's sort of communicating with the application. So now I'm ready to move on and install the client on my headset. So the next thing we're going to do is connect the headset to this virtual workstation. We first need to think about two things. Number one, the client, the CloudXR client needs to be installed on the headset. And number two, we need to push a configuration file that tells the headset what IP address to look for in order to connect properly. The second point is easily solved here. We've got the external IP here. I'll show you how to do that in a second. But I am using this brand new HTC Vive Focus 3, which comes with the client already installed. There is instructions in the CloudXR, in the quick start guide that point you to how to install the client on different headsets. They're different depending, the installation instructions differ depending on the type of headset you have. But check out those, the developer portal. You'll have to download the client. You'll have to install Android, in some cases, the Android SDK. It's not that difficult, but some of my other videos, I show you how to do it. So all that leaves us with is pushing this IP address to the headset. So I'm going to copy this IP. This is my external IP. And I'm going to plug my headset in using a USB-C cable. And in a terminal, because this is how I'm going to address it with using the ADB command line. So ADB devices -L will let me list the attached devices, and I could see that my Vive Focus 3 is connected. Next, we need to create a file called CloudXR launch options.txt, and you can see I already had one in my folder. And the only thing you need to put in it is -S and then the IP address of the machine, of the remote machine. So this is essentially a config file that gives it a source IP address to read from. So we edit that file using the editor of your choice. And then we're going to push this file to the headset. And to do that, we're going to use the ADB command, subcommand ADB push. So ADB push cloud launch options.txt. And the path on the headset is /SD card / and then the name of the file. It's just like a copy file. And that's it. If you're really interested, you can do ADB shell, and you're actually logged into the headset itself. So now I can look in the SD card directory and list, and there's my file. And you're in a shell, but you're in sort of a limited subset. So you can at least cat. I don't think you can VI. Yes, but you can see that that file is there. All right, so that's it. And now we could exit out of there and we could do ADB reboot. I like to restart the headset just to make sure that it picked up all the changes. And now we're ready to connect with our headset. So I'm logged into my virtual workstation using Teradici's PC over IP. Everything is installed. I've also installed a demo app called Welcome to Lightfields, which is an amazing experience showing light field technology developed by Paul Debevec and his team at Google when he was at Google. In the meantime, though, I need to launch Steam VR. You don't need to launch Steam, just Steam VR, and that's going to allow us to connect to CloudXR. This is sort of the portal through which the connection happens. So when I first launch, nothing happens, and it says headset not detected. That's perfectly normal. And I'm going to put on the headset, and I'm going to launch the CloudXR client from within my environment. Okay, you could see I'm connected via Cloud VR. And we could see in Steam VR, there's the headset is showing as it's active and connected. And I can launch maybe Welcome to Lightfields here. And you could see a few different overlays, and the application launches. And I'm now watching this application. I've got audio. I don't know if you can hear that, but I've got audio streaming over, streaming right to the headset's speakers, which is pretty cool. I can turn that up and enter. Oh, I don't want to raise the volume above the recommended level. I can look at any one of these really gorgeous scenes here. And this experience is for seated or standing only. It's not a room size. I think there's about a head volume of about 1 meter cubed, so I can sort of move around and get an idea of all the way the reflections play off each other. A really neat one is this stained glass window environment where I can look around and, remembering this machine, this VM that I'm streaming from is many hundreds of miles away in Las Vegas. There are debug settings where you could turn on to look at the latency and jitter and all sorts of metrics. But it's, suffice to say, the behavior is pretty good. And we're also seeing some of the statistics coming up here. We got, okay, it's 11 milliseconds, but this is the Steam VR metric of 11 milliseconds. I'm not sure if that's the latency to the headset or not, but there's all sorts of interesting metrics that we can gauge and look at and everything. So, all right, so this is one example of running a VR workload in its entirety from start to finish, but it's a single user, single VM, single deployment. Now, next, let's look at something a little bit of a bigger deployment. Let's look at how an enterprise application might be deployed across many users that require things like user logon credentials and machine provisioning and user provisioning and replication of an identical machine image so that everybody gets the same sets of tools and everything. So let's have a look at that. To begin the enterprise workflow, we could start with a simple spreadsheet. However, the spreadsheet does not need to be populated by hand. It could be populated by a Google form, for example. Every time a user submits their information, it filters into this here, these rows, it adds additional rows. You could also generate a CSV file any other way. Also, you'll notice here, I've got an example user that I'm going to create. I've sort of pulled out a few different columns or categories to sort of carry this as metadata into the user environment. So I could populate the region that the user will exist in and where their resource needs to be created with the city column, for example. If I create a CSV file of that, download CSV file, and now I can go over to my Okta admin panel, which has been set up in my environment. This is an Okta server running in Well, this is connected to, authenticated into an Okta server running in my infrastructure. And I can import that file and upload the CSV. And I'm going to click automatically activate new users. And what that's going to do is a couple things. Number one, it's going to create the user in Okta. It's going to add the user to my Active Directory server. If I refresh here, you'll see the user has now been created. However, the user has not been activated. So the user receives an email inviting them to activate their Okta account. And you can customize this per your organization. But when I click this, I'm taken to the welcome page to establish passwords and other credentials here. I populate passwords. I will choose security question. What is my favorite security question? Anyone? I'll choose security image and create my account. And the user only needs to do a couple things. They need to add the Radius application to their environment. And this could be done for every user, by the way, automatically. I'm just doing this manually. And now they can they could set up their Okta Verify so that they can create a push notification for their phone. I'm going to open the Okta Verify app and add based on organization and scan. And now I've established an Okta Verify multi-factor authentication method. And I'm done with this account. I can log out. So as a user, you could see it's fairly easy to be onboarded into the environment. Because I have an event hook set up to trigger when a new user is added, it set off a chain of events to create and provision a new workstation for this user, and then assigned it to the user, joined it to the domain. So let's have a quick look at what the user and machine resource provisioning workflow might look like. Well, you could create users like I showed you before with either a spreadsheet or via Google form or some other way to generate a CSV file. And all of that will populate user creation in the Okta admin panel, which can be done via the UI that you saw or via an SDK or a RESTful call. And what that's going to do is create the user in Okta and then populate that same user in the Active Directory server in my project, in my GCP project. It's also going to send an activation email to the user so that they can then start the process of creating an account and establishing a password, which will get pushed to the Active Directory server, and then establish a multi-factor authentication method to generate that push token. Meanwhile, an event hook is run on user creation as well when the user is tagged with a certain group. And that event hook calls a cloud function, which is essentially a signed URL that contains all the information necessary to do a few things. Number one, it builds the workstation on GCP, so it provisions the machine in a particular way based on the given image and in the right location, based on the metadata that's supplied in the cloud function. And it does a few other things, like it creates an asset disk, for example, which is a separate non-boot disk, the D drive, for example, that would be attached to a workstation for any user. And that, of course, also necessitates creating a roaming home directory functionality for the Active Directory server, so that is triggered as well. And then access is granted from the user's IP address via a firewall rule that applies only to their workstation and only from their IP. Of course, you need to go directly from your IP to the workstation IP, the external IP, when using CloudXR. But this could be, you could work around this with some sort of IAP tunneling or another type of sort of port forwarding method. And then some other standard Active Directory tasks like placing users and resources in particular organization units and establishing group policies. And then finally, once the workstation is created and all the other tasks are complete, the user is assigned access to the workstation via the TerraDG CAS Manager API. So now all the user is left to do is to download and install the PC over IP software client on their laptop or workstation running under Windows or Linux or Mac. And they're going to navigate to a fully qualified domain name. And we'll go in as GTC demo. And we're going to authenticate against our Active Directory server, but it's going to prompt us for our two-factor authentication. And I'll click Send Me a Push. I get Okta Verify. And I verify, yes, it's me. And I'm logged into my workstation. And we can see this workstation is pre-populated with software that I need, including Steam and Steam VR. Also, what you can't see here is the Unreal Engine editor and a bunch of other assets and libraries pre-installed, so that now I can put on my headset and launch directly into the CloudXR client. So beyond just looking at the CloudXR client, we can load an application like Unreal Editor. And this is a default template. I believe it's a Collab Viewer template as part of the games package. And it's got all of the controls built in for handsets. For example, I'm using the Oculus Quest now, not the Vive Focus 3, but all of those controls are built into this scene. There's a couple plugins you need to load to get Oculus controls to work. But it's a pretty interactive experience, and considering it's 10 to 12 milliseconds away, I can just enter into this environment and start moving around. And I've got, motion controls. And even if I go here, you could even see I'm getting the audio from the remote machine. And I can do more than just move around. I can, actually, you can go and got some physics capabilities here. I can maybe grab one of these, slide these things around, maybe get this a little closer to the edge, so I can now start, playing with some of these game assets. And the CloudXR is handling this really, really well, meaning it's accounting for all of the latency and all the jitter, and whatever other sort of bandwidth complexities that might be occurring. And it just gives me an experience that's pretty much the same as if the workstation was under my desk and I was maybe tethered. This is a tetherless headset, don't forget. So I'm running this over Wi-Fi to my Wi-Fi endpoint, which is on my home internet, which is connected directly to, which goes through my ISP to Google Cloud to over our GCP network to my workstation, which is, by the way, in the US West 4, which is the Las Vegas region. And the last piece of the puzzle that I want to show you today as part of this demo is leveraging the Unreal Engine Collab Viewer functionality, which gives you the ability to have multiple users dial in and connect via VR headset or 2D browser and interact and visualize the same scene so that they can collaborate across networks. And because we're able to do this in cloud, now you can have collaborators all over the world with their resources close to them, but all the traffic riding over the GCP private global fiber network. So looking at this diagram here, you could have multiple users dialing into separate regions. So we've got, for example, 2 users each running a software client. They all connect through a global load balancer, which is that fully qualified domain name through the Teradici software client that you saw me connect through earlier. And this diagram doesn't show any of the authentication through Active Directory and the Octaradius server, but once authenticated, the users are connected to through a connection broker in each region. And that ensures that there's a handoff that happens, that the traffic now flows from the client directly to the connection broker, which is as close as possible to the end user. They log into their workstation, so they've got their desktop activated, and then they put on their headsets, and their headsets connect directly to the virtual workstation. And of course, the workstations, 2 or more workstations, are all able to communicate via the GCP network, no matter what region they reside in. So now that we've seen what some of these workloads can do and what some of the scope and capabilities are today, let's look at what we could do in the future and start to think about how to build out these platforms and infrastructures to accommodate even more users and even more workloads. The first thing is to automate the scaling of it, whether that's through container-based deployments, lighter weight streaming. If you can quickly build and deploy resources and connect resources to users, and then deprovision them when the users disconnect, and be able to scale this in different regions all over the world, that's a huge benefit. And I think that's definitely a requirement for web scale. We also need to think about virtualization, and the next generation of GPUs are going to allow multiple users per GPU. So you could take a GPU and slice it into different slices. We're already seeing this on some of the compute-only GPUs, the A100s from NVIDIA that run in our A2 machine types on GCP allow this. It's something called multi-instance GPU, or MIG. Because those are compute-only GPUs, they're useful for HPC workloads and distributed simulation, that type of thing. But for virtualization, we need display-capable GPUs to do that, so that's coming. And once you do that, then you can run multiple users. You could have a containerized deployment, each with a slice of a GPU attached to each pod, and then scale those pods and migrate them to different hosts to make it more efficient, to get pod affinity such that you could bin pack properly and maximize the use of any host. We also need to think about how to deploy this as a platform. Now, once we have the ability to scale and virtualize, how do we offer this as like a single one-click connect to cloud? If I want to offer this as a service to users, they shouldn't have to have a GCP account. They shouldn't have to be any federated into any system other than the one that my company already federates them into. If you have a user account as part of a website or something, that's the only federation that should be required. And then they should be able to use that those credentials to be able to deploy using a customer's service, for example. And that's essentially what building a platform is. So we need VR as a service or augmented reality as a service. And we're already starting to see this with some of the 2D AR workloads that are offered from Google, such as something released a couple of years ago, which allows you to see automotive content. If you Google search for a car model, for example, you could click see this in 3D, and that will immediately connect you to an instance of Unreal Engine with that specific car model already running, and you could tumble around it and see it ray traced in real time. And then you can click a button and view it in augmented reality, so you could see this car in your driveway, for example. And that's essentially how you can sew this up into a platform to allow customers to access your service pretty seamlessly. And finally, we need to sort of make it a native part of the web. We need to define protocols. And this is obviously a bigger challenge than just having a single solution on top of GCP. We need to establish the fact that when you click something in a headset, for example, it knows to launch a particular client that will then connect to a particular resource on cloud and stream an experience to you. So that all of the experiences that we're seeing right now with for example, the Android environment, the Android OS that runs on some of these tetherless headsets, they could have a client app, for example, for CloudXR, or CloudXR could be a protocol that you might be able to use to sort of promote when you click a link. Instead of HTTPS : it has CloudXR : and it knows to connect and deploy to that via that protocol to that particular client. Now, there's some other really great CloudXR content that you should check out at GTC. And I've highlighted three of them here. The first one is where Volkswagen is training from the cloud using CloudXR, given by a company called InnoActive, which designed the platform. Some pretty cool stuff there. HTC is showing off its partnership with NVIDIA, being the first headset manufacturer to offer CloudXR client as part of the native experience of the HTC Vive Focus 3, like we saw me use today. And then finally, there's this really amazing session that has some CloudXR, some Omniverse, and some other topics being discussed, but it's a really great opportunity to watch a number of industry experts from NVIDIA, super senior solutions architects, discuss the state of virtualization and rendering and at the enterprise scale. So definitely check that session out. And finally, some other links for you to check out. There's a tutorial that I wrote for the last GTC, which shows you how to stand up a virtual workstation and install and deploy CloudXR. It does not incorporate the new marketplace solution that we looked at today. I'll update it as soon as I can. But it still shows you step by step how to do it. There's also some great documentation, very helpful from NVIDIA of the CloudXR SDK. You don't even need to log in to read that. You could just click that link. Some other things that I showed today, the VR template for Unreal Engine. There's some good documentation from Epic Games Unreal Engine on that, as well as how to use the Collab Viewer template as part of the Quick Start tutorial. And with that, I'd like to say thank you. Enjoy the rest of GTC. I hope you learned something, and get out there and check out those tutorials and the SDK and all the documentation. There's a lot out there to learn, and there's a lot of really cool stuff out there to